Here's a better graph to help us visualize what we just did in this example. We were given an annual revenue function. R of t. T is in years. That's on the horizontal axis. The vertical axis represents dollars. I'm just going to call that dollars like that. We were also given an annual cost function, C of t. At any t value, the difference between those so the height of that little line segment is the annual profit So what we did is we took the area between those two curves and that gave us total profit from time t equals 0 to, well, we were only interested in looking at that for as long as the revenue was above the cost, and we determined that the switchover happened at 8 years. So that area gives us total profit from t equals 0 to t equals 8. Now, there is another approach to this problem that might have occurred to you, and that would have been to say, well, since annual profit is annual revenue minus annual cost, why don't I get the profit function before I start doing any integrating? So you would get P of t equals 640,000 minus 10,000 t squared dollars per year. And of course, that was the integrand we ended up using. But you could start there and say, if I integrate the annual profit, which is the graph I've shown here, notice that's also an upside down parabola. Up here we'd be at 640,000. That's in dollars, and our horizontal axis is still t in years. And we already know where this x-intercept is, right? Because that's where the profit from the machine becomes negative, where the revenue is below the cost. So that would be at 8 years. And if we integrate the annual profit function, which is kind of what we ended up doing, this area then is the total profit from time t equals 0 to time t equals 8. Honestly, to me, this seems like the more straightforward way of approaching this problem. The reason we did it this way, though, is just because we're working on finding areas between curves. So that's the approach I used in this problem.